Hi, let's work on section 2, linear relations and functions still, but we're going to talk about linear relations. That's the most important thing. And functions. This is a function form. This is a linear function. Here's why. It has a simple form, and that form is just like slope-intercept form, only it's written in function notation, okay? And I'm going to write underneath it. I'm going to blow this up so you can see it. There it is. You see it over here? It says f of x equals mx plus b. Does that remind you of something? It should. It should remind you of slope-intercept form, which is y equals mx plus b, right? Where m is the slope and b is the y-intercept. It gives you a chance to be able to graph something because you know the y-intercept and you know the slope, so you can count up and over, right? That's getting back to what we did in Algebra 1. Now, we're going to talk about it in function form because functions are very, very important. And when you move on to pre-calculus and calculus, we need to talk about functions, all those curves that you see, and how we can find certain things on those curves. All right, so we're going to keep thinking about f of x being the same as y. All right, when you put it into one of these graphing calculators, it says y equals. It doesn't say f of x on it. All right, so you're going to be ready to do just that. So our example here says, is this, and I'm going to blow this up just a little bit, bring it down a little, there we go. It says, is f of x equals 0.2 minus x over 5 a linear function, and let's explain it. Well, let's rewrite it and make it look like something that we know. Let's just write y equals, and let's shift this around, negative x over 5 plus 0.2. All right? Is this in our slope-intercept form? You bet it is. Now, sometimes you'll write it as negative 1/5 x, but I don't really mind the fact that we have an x over 5. It's the same thing as negative 1/5 x, so why don't we just say it's negative x over 5? It's perfectly valid to leave it in this form. So I know they wrote it as negative 1/5 x, but I think it's still perfectly valid to leave it in this form. This is a much higher level idea of leaving something like this. We know we're dividing by 5. We know we're multiplying by a fifth. They're the same thing. Okay, so let's go ahead and leave it in this form. As long as your x is not in the denominator, and you can write it in this form somehow, then you definitely have a linear function. I'll repeat. As long as the x is not in the denominator, you have a linear function. As long as your x is not being multiplied by y, or your x is in a denominator, then you have a linear function. Both things it's the same thing, by the way, but I digress. Let's go ahead. This is written in a different form, isn't it? Well, is this a linear function? If, when I try to solve this and solve for 1y, can I do it? The truth of the matter is yes. Yes, you can do this, and it's really not that difficult. If you factor this, you can make this work. But suffice it to say, it has one of the two things that we cannot have. The first thing is x and y are multiplied together in the middle of our function. So that is no good. Let me go ahead and move along, and we'll look at the examples at the bottom of this page, and then I'll move on to the second page of this. I'm going to have to, well, I'll leave it blown up so we can take care of this. If we have something that looks like this, we know for a fact is x being multiplied by y in this? No. Can I rewrite this and solve for y so that I see I have an x and something extraneous over here? You bet. We add x to both sides. And now we have 6y equals x plus 7. All right, well, let's divide both sides by 6. This is a perfectly valid answer. Y equals x plus 7 divided by 6. This is a linear function because x is not in the denominator and it's not being multiplied by y anywhere. Okay? So we're still good to go. Number 2, we have a little bit of a problem, right? We have y in a denominator, so we're going to multiply by y, multiply by y. Wait a minute. Now we have 9xy equals 18. That doesn't help us. Why? Because x and y are being multiplied together in our function, and we can't have it. Here is what would happen if I went ahead and finished this out and solved for y. Divide both sides by 9x, and we would have y equals 18 divided by 9 is 2 over x. Oh my gosh, we have an x in the denominator, and x can't be in the denominator because if x is 0, this whole thing doesn't exist. We can't divide anything by 0. So we would have what would look like a line for a while, and then it would break off, and we'd have an asymptote. And I don't want to get you started on that because that's a long, long way away from where we are right now. Suffice it to say, x equals 0 does not exist. We could say that. Or we could say x is being multiplied by y. We could say x in the denominator doesn't count. All right. So those are our examples. If you go through those, it should be pretty easy. Nothing very, very difficult about this page. We already see an x being multiplied by y in number 9, so we're going to get rid of that right away. We see y equals 4 over x. We have an x in the denominator. That doesn't work. This is all very, very easy stuff, right? This x cubed thing, as soon as this has a power, a bigger power, no longer linear, okay? So x to a power greater than 1, because that's what it says on the top of the page. No good. All right, x to a power greater than 1, no good. This thing here, this looks fine. This looks fine, and this looks fine. Number 5 looks fine as well. I think number 6 is good. I haven't looked at it, but I'm going to assume it's okay, only because I want to move on to page 2, but I'll slide it over just in case. Yeah, no good. With a y in the denominator means an x will be in the denominator, or you're going to be multiplying by y. So I lied to you. Number 6 is no good. Let's move on to the second page, and let's read what it says. Let me shrink this down just a little bit so I can move to the top of the second page. This is the fun part. We're going to move our equations. We're going to put them in standard form. Standard form is ax plus by equals c. You've written equations in standard form in Algebra 1. We're just going to repeat this skill. And all we're going to do is, if we can write it in standard form, we're going to label what is the a and what is the b and what is the c. So here we go. Y equals 8x minus 5, okay? All we do is to write it in standard form is subtract 8x from both sides. We don't like a negative 8x for some unknown reason. So we're going to multiply everything by negative 1, so we end up with 8x minus y equals 5. So A would be 8, B would be negative 1, and C would be 5. I'll work some down here in the exercises so we can get to it. Here's another one, written in this form. 14x equals negative 7y plus 21. What's missing? We need to put this 7y over here, so we're going to add 7y to both sides. That's what it says, add 7y to each side. So we're going to end up with 14x plus 7y equals 21. We don't want 14x's and 7y's, so we're going to divide everything by 7. Right? We have a common factor, so let's divide everything by 7. 14 divided by 7 is 2, 7 divided by 7 is 1, and 21 divided by 7 is 3. Do I have to do that? But I'd like you to, okay? We need to have it in its simplest form for our purposes, but you see how we got there. So far, so good. Let's do those exercises first, and then we'll come back to part B, which is graphing. All we have to do is put it in ax plus by equals c form, and this needs to go over here, right? So I'm going to do it. I am going to subtract 4y from both sides, minus 4y. All right? And when I do that, that goes away. I'm still here with negative 1. I have an equal sign, and I have 2x plus, minus 4y, because I subtracted 4y, equals negative 1. Now, it's pretty simple. I could divide everything by 2, but then I have a half. Let's leave it like this. So A equals 2, B equals negative 4, because there's a minus sign in front of it, and C equals negative 1. Sounds pretty easy, right? Here's the next one. All I want to do is subtract 2x from both sides. Now I have negative 2x plus 5y equals 3. Well, I don't want to have a negative 2x, so I'm going to multiply everything by negative 1, which gives me 2x minus 5y equals negative 3. My lead term needs to be positive, and now I have A equals 2, B equals negative 5, and C equals negative 3. And that's it. This is a pretty easy thing to do. If it's mixed up or messed around, all right, not a big deal. But I think we have a handle on what's going on here. If you have any questions, always remember to ask questions by sending me messages or see me in class, and I can go through it. But if you send a message on Google Classroom, I get it. So go ahead and ask as many questions as you want. I can answer you. All right, here we go. First things first, if you put your equation in slope-intercept form, then you're going to be fine. But we don't have it, right? We're not in slope-intercept form right now. So here's what we want to do. You've been given an original equation in ax plus by equals c form, right? And all we have to do to find the x-intercept is make y 0, and to find the y-intercept, make x 0. All right? Let me say that again. To find x-intercept, make y equals 0. To find the y-intercept, make x equals 0. That's what it says over here. I'm going to show it to you again right there. To find the x-intercept, make y 0. To find the y-intercept, make x 0. Oh, well, that's super simple. Let's go ahead and do that. Let's find the x-intercept. This says find the x-intercept, the value of x when y equals 0. So we put in a 0 for y, and we have 4x minus 0 equals 20. Therefore, x equals 5. Well, that's the x-intercept. All right, so we make a dot on our graph at 5, 0. Right? Because we said that y was 0, by the way. All right. Just something silly. All right? But I want to find the y-intercept too, because I need 2 dots to make a straight line, right? I need 2 points, and then I can connect the dots and make a straight line. So let's go ahead and find the y-intercept. If we want to find the y-intercept, we take our 4, we make x 0, negative 5y equals 20. Okay, well, if that's 0, negative 5y equals 20, we divide by negative 5, divide by negative 5, and y equals negative 4. There you go, you make your dot at negative 4, you take your straight edge, you put it on your graph, and you go ahead and connect the dots and put arrows on both ends. And there you have it. That's all you have to do. I'm going to take the first example down near the bottom of the page, and we're going to go ahead and do it. I'm going to leave this up there just in case you can see it while we're doing the work. Let's drag it all the way down. Excellent. We love this. This is going to be excellent. Nice and simple. To find the x-intercept, let's make y 0. So we're going to say, okay, sir, 2x plus 7 times 0, that's our y, we make y 0, equals 14. Great. That's 0, so 2x equals 14. Everybody knows that 2 times 7 is 14. There we go. So we say that x is 7. We count to 7. 1, 2, 3, 4, 5, 6, 7. We make a dot. So far, so good, right? Let's make x 0 to find our y-intercept. So 2 times 0 plus 7y equals 14. All right, well, 7y equals 14. Y has to equal 2 because 7 times 2 is 14. So we go up to 2 on the y-axis. This tells me where on my y-axis, this tells me where on my x-axis, and then I take my straight edge, just like I did before, and I put it here. Let's see if I can make this work right. I connect the dots, and I stick arrows on the end. That's all you have to do. That's everything there is for these 2 pages that you have to do. For these, 2 sections. 4 pages, 2 sections. Very simple stuff. If you have any questions, be sure to let me know, and I'll get back with you. And we are going to be moving. Way to go.